So in problem 3-4, we look at what they call a life table extracted from G82M, and then they say, well, complete it and interpret it. So maybe it's best if we do it the other way around. We start by interpreting it and then completing it, because by interpreting it, we will actually get to know what the Lx, dx, and qx mean. So the way we normally construct a life table is we take a homogeneous group of people. So we take loads and loads and loads of people who are all born, for example, in 1905, maybe. And then we look at them and we say, okay, so we take 10,000 people from this year, or we take 100,000 people from this year, and at age 0, 100,000 of them are still alive. Then we count them. How many are still alive at age 1? How many are still alive at age 2? And so on and so on. And based on this counting, we will be able to say how many died between age 0 and 1, how many died between age 1 and 2, and so on and so on. And we will also be able to come up with a ratio of how many people of those surviving died. So what was the probability of death within that year for any given year? So that's kind of the background for this. So if we were to try to understand the whole Lx, dx, qx thing, how should we understand that? Well, what we're looking at is a timeline where we consider ages x and x plus 1. And the way to interpret Lx, it is the number of people that have survived past year X. So it's number of survivors past year X. So quite clearly, for each year that passes, people die, so the number of survivors dwindles, it decreases. So we're quite sure that Lx plus 1 will be smaller than Lx, and Lx plus 2 will be smaller than Lx plus 1, and so on and so on. So we need a letter to signify the number of deaths between the age x and age x plus 1. So we use the letter D for death. Dx is number of deaths between ages x and x plus 1. And what we see here quite clearly is dx is just the difference between the number of people who were living at age x and the number of people left at age x plus 1. So that's Lx minus Lx plus 1. I guess we can also see this in the book on page 25. So D stands for death. I'm not really sure what the L stands for. It can either stand for living or left, in the sense that you are one of those people left who are not yet dead. It's kind of macabre that way, but I'm not really sure what the L stands for. But we do have Q as well, QX. So QX is the probability of death for an X-year-old within 1 year, with the invisible 1 up in front of the Q. And it is actually just the ratio there is between number of deaths and number of survivors. So in the book it tells us that TQX is given by LX minus LX plus T. So in our case, our T is just a 1 here, divided by LX, which in turn is just equal to number of deaths over number of survivors, age X. So we will use this expression and this expression to fill in our table. Now, just before I go on to the next table filling video, we could also probably talk a little bit about what the Q stands for. To be honest, I am really not sure. Just except that I know quite clearly that normally we like to use P to denote the nice probability. So that's also why we use it for stuff like survival and stuff. And we like to use Q to denote the less nice probability. Maybe it's because Q stands for quitting or something. I'm not sure. But anyway, those are probably some mnemonic devices that you can use to remember these biometric functions. So next video, we'll fill in this table.